Hello everyone, today we're going to divide radicals. I'm going to teach you on how to get the quotient of radicals of the same index. So, let us have an example. Give the quotient of the following. Number 1, let's say we have a square root of 25 divided by square root of 5. Okay, let us rewrite this. We have a square root of 25 over square root of 5. So, using the quotient rule for radicals, that if a is greater than or equals to 0 and b is greater than 0, then the nth root of a over the nth root of b is equal to the nth root of a over b. Okay, so we have square root of 25 divided by 5. This is equal to square root of 25 divided by 5. We have 5. Now, since that 5 is not a perfect square, so this is the answer. This is the simplest form of number 1 example, or the quotient of square root of 25 divided by square root of 5. Next, number 2. Let's say we have a square root of 32 x raised to the 5th power, y raised to the 6th power, divided by square root of 8xy. Okay, so we have a square root of 32 x raised to the 5th power, y raised to 6 over square root of 8xy. Now, using the quotient rule for radicals, this is equal to square root of 32 x raised to the 5th power, y raised to 6 over 8xy. Now, let us divide 32 divided by 8. We have 4. Then x raised to the 5th power over x raised to the 1st power. So, what are you going to do is you just subtract 5 minus 1. We have 4. Here we have x raised to the 4th power. Then for y variable, 6 minus 1, we have 5. So, y raised to the 5th power. Then, as you can see, square root of 4x raised to the 4th power, y raised to the 5th power is factorable. So, we have square root of 4x raised to 4, then y. Since that the exponent is 5, you're going to think of a number less than 5, which is divisible by the index 2. So, we have 4. Then, the remaining one, you should write it here. Okay. Then, we have square root of 4x raised to the 4th power. Y raised to the 4th power is, this is 2xy. Then, square root of y. This is the answer for number 2. Okay. Next, number 3. Let's say we have 2 divided by square root of 5. Okay. Here, as you can see, the denominator is a radical. Okay. So, what are we going to do now is we're going to make use of rationalization. What is a rationalization? So, this is the process of eliminating the radical in the denominator of a rational expression. Okay, so going back to our example, we have 2 over square root of 5. So here you're going to think of a number that will make the denominator a perfect square. So we have here, you have to multiply both the numerator and then the denominator by square root of 5. Okay, over square root of 5. Okay, then 2 times 1, so that is 2. Then you will just copy square root of 5 over square root of 5 times square root of 5, that is square root of 25, right? Then you copy 2 square root of 5 divided by square root of 25, that is 5. Okay, you cannot cancel square root of 5 and then 5 because they are not similar terms, okay? So the answer for number 2 is 2 square root of 5 over 5. Next, number 4. Let's say we have square root of 7 over 3. So here you're going to make use of the quotient rule for radicals, square root of 7 over square root of 3. So make this one as a perfect square so that you can get the whole number or to remove the radical in the denominator. So we have to multiply this by both the numerator and then the denominator by square root of 3 over square root of 3. Then let us now multiply radicand to radicand. We have 21. So square root of 21 over square root of 3 times square root of 3. That is square root of 9, or simply that is 3. So square root of 21 over 3. Okay? Next, number 5. Let's say we have the cube root of 6 over 2x. So using the quotient rule, we have the cube root of 6 over the cube root of 2x. Now, we're going to make the denominator a perfect cube. So that is, we're going to multiply both the numerator and then the denominator by cube root of 2 squared, okay, x squared. Now, since the exponent of this is 1 and then this one is 1, so to make this divisible by 3, you're going to multiply both the numerator and the denominator by cube root of 2 squared, then x squared. Okay? Then over cube root of 2 squared x squared. Then, let us now multiply. We have cube root of, so 2 squared is 4 times 6. We have 24. Then x squared. Okay? Then over this one, let us multiply. Okay? So we have the cube root of 2 raised to 1 times 2 squared. So this is equal to 2 cubed. Then x also, 1 plus 2 we have, 1 plus 2 we have 3. So x cubed. Then, notice that 24x squared has factor wherein it is a perfect cube, right? Which is 8. So, we have 8 then times 3x squared. So notice that the exponent of x is less than the index 2. So it should be written here on the non-perfect cube factor. Then over cube root of, let us simplify the denominator, cube root of 2 cube. So this is 2. Then cube root of x cube, we have x. Then we have cube root of 8, we have 2. Then you will just copy cube root of 3x squared over 2x. Now, since that you can cancel 2 and then 2 here, the denominator, so we have now the answer cube root of 3x squared over x. Okay? This is the answer for number 5. Okay. So we're done with dividing radicals. Now for more videos and updates, please do like, share, and click the notification button for more videos and updates. Thank you.